Hello, everybody. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. And before we get into topics, we are going to shout out the fact that we are doing a training on hacking hypervisors. Now, we've shouted out the Hardware IO one a couple times. That's taking place from May 27th to May 29th. But we also have been accepted to Recon. So that's going to take place in Montreal, and that's in June 23rd to June 26th. That one is a 4-day training, so it's going to be a little bit expanded. We're going to go a little bit deeper into the advanced hypervisor security mechanisms for the mobile hypervisors mainly. But yeah, so this training is going to be talking about a range of different hypervisors from KVM to also talking about like Samsung's Knox and the mobile hypervisors there. So yeah, if that sounds like something interesting to you or someone you know, then we'd appreciate the recommend. And yeah, so with that out of the way, we can get into some of our topics. So our first topic is another post by Mickey Jin, and this one's on a vulnerability in Parallels Desktop that was reported to both ZDI and Parallels, and still remains unfixed after 7 months. So a little bit of a crazy timeline. Of course, there is a bit of drama and stuff to get into with ZDI there, but the vulnerabilities are kind of the old, tried and true file system problems. So I'll let Z get into it.
Yeah, I mean, we've talked and talked and talked about time of check, time of use issues when it comes to a privileged service executing a. I won't. When it comes to a privileged service executing another binary that'll get those privileges that it has, which is exactly what's going on in this case. It's one of those cases of basically Repack OSX cell here. This runs as part of Parallels. It's running as like a root process, and it's going to do this it's going to run this create install media, and it'll run that as root. And I believe the original vulnerability they called here CV 2024-34331. I believe that one was like just you could basically just run whatever or get it to execute whatever.
Yeah, no signature check.
Yeah, and then to patch that, they've added in a signature check where they call in code sign -r anchor apple and then what they're actually about to run. So effectively what they're saying is that the code sign needs to test, so -R is the one for verifying, -r is, actually I forget what -r, lowercase r does. It's another thing with the requirements. I think it might be used when doing the code signing, whereas it doesn't matter. Anyway, what's going on with this code is that it is basically just saying, like, anchor apple. So it's basically just anything that has been signed by a Apple certificate, like the anchor is Apple. Like some certificate down the line signed by Apple, you're good. Like it'll run any binary as long as it's Apple. And that feels somewhat fair. As like a developer's thought, okay, we'll just let it any signed Apple. Like, yeah, there's a lot of signed Apple binaries, but like they can generally be trusted.
Well, it should be more granular.
It should be, yeah. Like ideally, you'd want to, but like I get the developer's thought of like Apple, they signed it, it's probably okay. Sorry, I might have kind of interrupted you though.
Well, I was just gonna say it did cause an issue though, which I guess you're gonna get into. Yeah,
yeah, of course it did cause an issue because, well, so there's two issues. One is just there's still a time of check, time of use issue. So you can just replace the binary after the signature has been, verified. So you have like that very classic time of check, time of use issue. But even if you didn't have that, the fact that it's being signed, just looking for that Apple, is anything Apple signed can be used. And so their kind of attack strategy here is just take like a pretty benign Apple signed binary and inject a shared library into it. Which as a user, like shared library injection, you can do to your own processes relatively easily. Especially things that aren't like intended to be run as like other users. So they use like ls. The system command ls is of course going to be an Apple signed binary. Have it load the DLL because ls isn't really thinking about being used as like a privilege escalation. That's not really the point. It runs as your local, or runs as your actual user. But in this case, it'll run with higher privileges because it is Apple signed, and so when you're able to inject a shared library, you have your own code executing, you control that code, that is now running with privileges. So, yeah, the attack there, I found that one to be kind of an interesting attack, just an interesting scenario where you're using a pretty benign binary because it's signed, and one that isn't like doing a lot of defensive mechanisms because it's not meant to be like run with privileges. Like, I guess you could like sudo ls to read something or whatever, like read into a directory you don't have access. In order to do that, like you don't gain privileges from running it. So like it's not sudo does the protection in that case.
Yeah, it's cool. It's like a side door kind of aspect to it. I agree. I like that attack strategy a lot more than the talk to because it's
Yeah.
it's more interesting.
Yeah, I mean talk to is easier. Talk to works, so like fair enough. But I do like that one more. One of the things that comes up here, though, is they initially reported this. So they had the original post of that 2024 CV was posted on May 30th. And then on May 31st, so remember, they started searching into this one, seeing that original post, and be like, this patch doesn't seem secure. Let's indeed bypass it. Reported over to ZDI on May 31st, a day later. And then ZDI took 6 weeks to respond and basically just said, yeah, we couldn't reproduce the exploit on 19.4.1. However, when they reported it, the newest version was 19.4.0. So basically they were testing on different versions, and they go into a little bit of their research into why didn't it work. And it wasn't patched. They had to modify things a little bit to get it working. But like the bug itself still existed, or the core issue still existed. So they go through, they update their exploit to work on the newer one, and they're like, well, this time they don't trust ZDI, so they're not going to report it to ZDI again, even though they kind of already did. But yeah, so they reported over to Parallels. Parallels, says they'll analyze the report, and then you can see here for 7 months, or how many months is that? Sorry. Yeah.
It's 7 months, yeah.
Yeah,
they just get ghosted, it looks like.
Yeah, I got
according to their timeline.
Yeah, I got tripped up by the October date there, and I'm thinking like, okay, October to the end, but yeah, no, 7 months from where they actually heard something back. They basically asked for updates and get no responses, so Parallels doesn't respond for months, including some months gap in asking for updates. They just disclose that. Again, my usual thing is I was like, at least let them know you're about to disclose that like 30 days beforehand or whatever, but they weren't getting any like response back.
They had
like,
no communication channel.
Yeah,
at that point.
And we also don't know what was included in there. They very, very well may have included some information about that. It doesn't really matter. I did feel like they judged ZDI a little bit harshly though. Like 6 weeks is a long time to get back, but ZDI definitely isn't known for their speed in terms of responding to any sort of reports. Like ZDI is one of those companies that you kind of expect them to take a while to get back to you. So on the timeline, like I get the feeling where like, yeah, 6 weeks is a while. Like it's not, you don't want to sit there for 6 weeks just waiting. When it comes to the version they tested on, we were kind of discussing this a little bit before the episode, and then decided to save it. But sorry, if you want to explain it, or should I?
Yeah, I'll go into it a little bit. So the core like problem here, especially with like taking 6 weeks to fix the issue, is Z had reminded me that ZDI wants to test on latest. They don't want to, they're not going to pay out for a bug that's been patched. So they want to test on the latest version. The problem is when you wait 6 weeks to even get back to the reporter, like that's an eternity in software development lifetime for an actively maintained product. Of course, there's going to be updates pushed after the report if you take 6 weeks to respond to it. It's not reasonable to expect the researcher to, have to forward proof their exploit and like expect it to work on latest. I think ZDI should have been testing this on the version that was latest as of the report. And then afterwards they could figure out if the bug has been patched, or like if it doesn't work, then why. But again, like if you're waiting so many weeks between responses, how do you keep up with the update schedule and figure all of this out if there's that much of a delay? Like it's not really reasonable. So like if ZDI is going to push hard on that, wanting it to work on latest and having to have the proof that it works on latest, then they really need to work on getting their communication faster between researchers.
Yeah, like I can see. I kind of go in a sense both ways on this. They're going for 0 days. Like they want 0 day initiative. They want O days. So testing on latest, I don't see like the major issue. I agree with you. Like the speed kind of sucks. I think in a lot of cases though, exploits are still going to be relatively stable across that. Now, to be fair, there are some types of exploits that um, are going to be very dependent on the version, and like you can't future proof it at the time you submit it in order to do that. Although I'm not sure what degree of exploit, because CDI doesn't expect like productized exploits, because their main thing is selling the fact that the vulnerability exists. So you just need something that's still going to act as a proof of concept and not necessarily fully weaponized. So the cases where I imagine a lot of those little changes, like in memory corruption bugs, you'll have like a little change, changes the structure and breaks everything. But you could still likely trigger a vulnerability, trigger a crash regardless, which should be enough for a triager. At least in order to like keep going like further on, go further into the process. So I get them testing on there. This particular bug, like because it's not like it was patched. I wouldn't expect the triager to need to do the effort to like figure out why it got patched or why it's not working. Sorry. Like I get the future proofing. I don't have statistics on it. I feel like the 6 weeks isn't going to break that many exploits in the grand scheme of things. Like you'd need an update in that specific area or something. Like it can. I'm definitely not disagreeing that it can break exploits, and you're able to like keep communication going. I believe once they start triaging, they do tend to respond quicker. I'm not. Again, it's more reputation based, so I don't have like statistics on their response time. It's not like we have access to that. But I believe like once you kind of have the triager assigned, if you were to respond, like they do get back a little bit quicker. Still not like same day or something like that you'd expect. And honestly, like the response time is interesting. I do wonder why ZDI's response time always feels so slow.
Yeah,
Uh,
it's funny because the 6 weeks in particular stood out to me because I reported something to ZDI years ago, and that was about how long it took for them to respond to me too. And my my circumstance was extremely similar to this one because the response I got after 6 weeks was, "Oh yeah, we weren't able to reproduce this issue." And like that's really like disheartening to receive after waiting so many weeks for a response. Because keep in mind, like that 6 weeks is just for the initial response. That isn't for the report to be resolved. So like you don't even have any means of working on it or like trying to work with them to get it fixed until that 6 weeks. Like that's insane. And like you, I don't know why it seems to take so long. I don't know if they just have a small team and they're just getting bombarded with vulnerability reports for different vendors. I don't know if it's something like that, but
it's just
having
one
like a
guy
six
in a
week
basement.
but having like this timeline of weeks to get back to a report and wanting to make sure things work on latest, like it just doesn't work. You can't really have your cake and eat it too in that sense. I feel like.
So, like, we don't hear about that 6 weeks creating or like that delay creating that many issues. Like, that isn't a complaint that I hear super frequently. Although maybe it's because a lot of people where it does have an impact then just work with them to be like, yeah, it's not patched. I just need to update this thing, and like it just has a little bit more back and forth. In your case, did you have any further back and forth after like you got that initial triage?
No, I didn't.
Okay, so
um
you don't know the time frame, or like you don't have direct first-hand experience on the time frame there. Fair enough.
no, because honestly, like I said, I was really disheartened after I submitted and waited 6 weeks and then just got back like because I won't go too much into it, but like there wasn't even really a lot of information in the response talking about what they tried or like to kind of direct me on how I could have helped them. And I was just kind of frustrated at that point and I just kind of gave up. And unfortunately, I don't think my experience is isolated in that. I think that ZDI's process being so long and delayed and tedious has driven researchers away from reporting through ZDI and instead going through other means, whether that be going to the vendor directly and just not getting paid for it or dropping an O-Day publicly. Like, I feel like people have been driven away from ZDI's process because of how off-putting it can be. And like you said, it kind of has a reputation. Like, this isn't an isolated incident. This is kind of how, business as usual at CDI, it seems.
Yeah, and honestly, thinking about it, so a few moments ago, I made the comment like you don't hear about this complaint where the 6 weeks actually create problem, but at the same time, now that I'm thinking more about it, I don't hear that specific complaint, but obviously the fact that it took 6 weeks is a very common complaint. And I don't have like a lot of feedback on what exactly happened after that. Just like it took them a long time to get back to me the first time. And the fact that they had trouble triaging is another common complaint. Not specifically on the 6 weeks, like it didn't work because it updated or whatever, but just generally problems triaging. Not necessarily even version related.
Yeah,
Although,
like if you're gonna take so long to respond, you would kind of hope that at least the reason it's taking so long is because they're trying to be thorough in their testing and triaging, and it doesn't seem like that's the case.
yeah, and another thing though is like it's a hard like triaging is a hard job.
It
Like
is.
being the person who needs to triage, especially like it's a one thing if they work at parallels or whatever and they're triaging an incoming bug, versus they can get CDI will accept reports on like anything. Um,
Yeah,
so like whoever's
that is a point in
triaging
their
kind of
favor.
needs to understand all these different programs. So like it does lower my expectations over what I'd expect a triager to actually do. Uh, just because like that it's hard work. Um
I totally agree. I'm not trying to dismiss it as if like this should be easy or whatever, but I mean, if that's the case and that they're getting slowed down and bogged down because of how many things they accept reports for, then maybe they should be narrowing their scope. Like it, I don't know. It just seems like they should be trying to change something to improve their program a little bit because it's been this way for so long. And it's unfortunate because like I actually really like CDI and their program. Like in theory, a lot of it is very cool. I like their tier and reward system. It provides a good avenue for researchers to disclose bugs if they don't want to go through gray market or don't have the connections to do that. They can still report to the vendor and they can get paid for it. Like it sounds amazing, but it's held back kind of by its implementation. um and it seems like outside of pwn to own, it's just really hard to get any communication going, which sucks.
yeah, and I, I think part of it could just be like I wonder what type of profit they actually get from running CDI. Because this isn't like their main business. This is Trend Micro, so they do like the security products in general. And like they have a much wider offering than just ZDI. But then CDI is funded basically. You get like corporations and such can get a subscription to know about these vulnerabilities ahead of time. So they kind of have like no day vulnerability alert feed sort of deal where like people get information about the vulnerabilities existing so they can maybe patch ahead of time, patch before it gets public or official patch and like have that. So I don't know what they actually profit off of that, but it does feel like they might just be running a pretty tight ship also in terms of getting that profit from the subscription, but then a lot of that's probably ending up back in the hands of the researchers who actually find the vulnerabilities for them to be paying out anything. Like, they don't pay out gray market rates, they're not competitive with the other rates, but generally speaking, there also aren't bounties on a lot of what they accept. So, like, the corporations aren't paying them for reporting it or something either. Main exception there is like Pwn to Own, where they're kind of working with vendors who often do have bounties. Like, Google Chrome has often been part of Pwn to Own, and of course they have a big bounty, or Microsoft, some Microsoft stuff, things like that. But yeah, I do wonder just if part of it is just like it's not really that profitable on their side, and so they have to run like a more lean company. Maybe, I don't know. I mean, that is purely speculation because I don't know anything about how much they're paying out in total, how many reports are coming, like basically any of the information you actually need to know about in order to say that. But it feels like
I kind of
be.
know what they pay, like their rough rates of what they pay researchers, but like how many reports they're getting and how much they're paying out in total is, yeah, it's impossible to know really. Outside of Pondone, of course. Pondone, you get that insight, but those are isolated to those events, so it's not quite the same. I wouldn't count it the same way.
Yeah, and it's hard to
So
even make like an educated guess. Like, yeah, I know rates on some types of bugs or like on some targets, but at the same time, because they have so many targets, like you can't really apply that and be like, oh, well, they pay out on this, so therefore, you'll probably get this payout on this other target. Like there isn't necessarily a clear connection.
yeah, but yeah, I mean it's very interesting. As you say, the blog post here is fairly harsh on ZDI, and like you, I do kind of feel bad for ZDI, or at least the people that work at ZDI, because I don't feel like it's, you know, I don't think it's like some cartoonishly evil thing where you have people at ZDI, these triagers, and are like, oh, today I feel like screwing over this researcher. Like, I don't think they're intentionally trying to take this long and make the process as difficult as it is. I just think that their process is flawed, and for whatever reason, they don't want to like try to address that, make it better. Um, and it can lead to some scenarios like this. Now, I will temper back, I guess, a little bit and say that you're probably right, and that this case probably isn't too common. Like you said, a lot of the time when things are broken by updates, and it's not just patching the vulnerability, it's usually hitting the exploit side. It's usually like a structure change or a code flow changed, and like the primitive, like the way you take advantage of a primitive is changes, but the actual like initial point of access doesn't change unless the bug is patched directly. So this kind of case probably isn't that common, but it is just one example of the kind of problems you can run into when you have such a delayed process and communication. So
Yeah, and I will say I do feel like it could be alleviated a bit if if the communication after first triage is actually quicker. Like if once you have somebody who's done this, and then like your next response is like the next day, then it would be a lot easier to like do that back and forth you were talking about.
yeah.
I don't know if that's the case though. I mean, oftentimes a lot of the discussion just focuses around that initial time and the final payouts, and not so much on the process in between. At least that I've had.
Yeah, but overall, like sort of an interesting bug too. It was kind of funny while we were talking. I was reading the last bullet point of the article, and they actually say that Parallels had reverted the change that Z had mentioned on 19.04.1. So the original exploit works again on like the latest version. So it seems like this area of code, at least, is just having some weird changes on Parallels side too. Um, you have this thing where like we've talked about ZDI a lot, but Parallels as a vendor has been really weird as well. And you know, in fairness, like we were talking about ZDI and their long response time, at least ZDI sent a response. Parallels didn't like, well, Parallels said they'll analyze the report, but then like it just was nothing for months. So
They're still analyzing it to this day.
yeah. So it's just I feel for the researcher here. I understand some of the frustration for sure.
Yeah, and thanks actually for pointing that out, because when I was talking through the bug, I was looking for some that said they had that regression, because I had remembered reading it that they had reverted the change there, but I'm like, well, where is it? Because it's not right by where they're talking about it. So I kind of changed how I was talking about. But yeah, they kind of had a regression there too.
Yeah. So very interesting. There's been some discussion around it, but yeah. So we do have some other vulnerabilities to get into. So our next one here is by DevCore. and it is about the half-day threat and Libarchive vulns lurking in Windows 11. So for a while, Windows has had integrated support for zip files, which I'm sure a lot of you have seen if you use Windows. I use it occasionally on Windows 10. You can open a zip in Explorer, go through it, extract things out, put things in. It works fairly nicely for the most part. What I wasn't aware of, since I don't use Windows 11, is that in October of 2023, they actually added native support for other archive formats too. So they have support for RAR, 7-zip, a bunch of other ones. So, of course, the researchers here wanted to look at it, see if they could find some bugs. And when it comes to file systems and zip functionality, there's plenty of opportunity. Everything from path traversals to symlinks to talk tos. And in fact, the first vulnerability is a path traversal. So they tried putting file names in an archive that had dot dot slash as a prefix, and when trying to open the RAR in Explorer, they found it was empty. And the temp folder didn't traverse out of the archive's temp folder, so it looked pretty good. If you tried to extract the archive as a whole, it would error out, saying the destination file would land outside of the destination directory, so that seemed like a dead end. But what about absolute paths? Well, if you go to extract an archive with a full absolute path, with like the C drive letter, for example, it would create a folder with C underscore for the drive letter and not actually traverse. So it would kind of do that substitution. But if you open the archive in Explorer, it would show the C drive as it would in the like My Computer tab or whatever. And furthermore, it uses the actual C drive folder as the temporary directory for the files. So a bit of divergent behavior there. Kind of fun, not necessarily super useful. It does give you an arbitrary file write into an unintended directory, but that file write still happens as the same user. You're not escalating privileges. You're not getting the ability to write into folders you shouldn't be able to, for example, like as that user.
Well,
But the
so
root cause was kind of interesting.
before you go into the root cause, just want to jump in. The other thing is that right, I believe, only happens when you actually navigate into that folder.
It does, yeah.
It's like it's also delayed. So, like if you wanted to exploit this to target a specific thing, it's like, oh yeah, you want them to overwrite, something in like C users username, .ssh or something. You'd have to have them like navigate to that folder through your RAR in order to have it write the file. So like,
Which isn't super unreasonable, but it is a user interaction.
that is a very, I would be very suspicious, and they call it out here that this would. Oh, where did they? I'm just trying to find it here. Yeah, it's that's CV, a funny yet useless vulnerability to exploit or create, delete in specific location. You need to create the exact same path structure and trick the user into opening every folder. Most people would probably find it suspicious halfway through the process. And I'm kind of on that side. I mean, one, seeing like your existing drives and folders in there is already going to, queue something up. At the same time, maybe somebody who's less tech savvy isn't going to notice some of that aspect, but yeah, it feels. Yeah. I don't think it's very, like, that is a significant social engineering feat to exploit this one that I feel like you'd be able to find an easier social engineer. Like, something easier than this.
When I made the comment about it not being super unreasonable, I was kind of thinking of the case of someone just mindlessly navigating through an archive, which, I mean, does happen. But yeah, you would kind of have to get lucky that they wouldn't get suspicious about it. Trying to social engineer this behavior, I don't think would be super practical, but just having like a zip that is malicious, like let's say on a torrent site or something, like you torrent it and you browse through it, like I could absolutely see that hitting some people. But
I could, although I also, like, where I might push back a bit is the fact that using the other methods of exploring, because this is divergent in that this impacts the one flow that doesn't do this replace invalid characters. That's one of the flows. So anybody on that torrent site or something that pulls the archive and hits those is going to be like, oh, there's something messed up about this. Like, there's a problem here.
Yeah, that's true. Yeah.
And, it's just another
thing. It
still
could hit some people, but yeah.
Yeah, it is a fair, like, I hadn't considered that. Like, that is a fair thought on where it could be used. I hadn't thought about just, like, mindlessly browsing through, but I still don't think
Yeah.
it's going to be practical at all. It is a
No,
cool
not
bug,
super
though.
practical
I
in most
actually,
cases.
yeah, I do actually like the bug. Like, it's a weird behavior. It has a bit of an impact, nonetheless. Like, I like the bug, and it is one of those things where it's just like one path does something differently than all the others. And it's kind of one of those things where I talk about having like the centralized security in terms of like, doing that at a level so the developers don't need to remember to do it every time they do some process. It's just done as part of it.
Now, continuing the theme of incomplete patches, this bug did have some variants in incomplete patches too, mostly due to the fact that in Windows, you can have your typical path style with like the drive letter colon slash whatever, but you can also have just like your what you typically see in Unix with like a root slash. That also works as well for the primary drive. So while they fixed the drive letter path, the slash root path still worked. There were also some memory corruption bugs they talk about. So there was like an out of bounds write in this copy from LZSS window to UNP function, where the length of the LZSS data was used as a signed int and then passed into memcopy. So kind of your classic unsigned signedness issues. Similarly, there was an int overflow in like an execute filter function. A couple of other ones. I'm not going to get into them. They're not really super interesting, but it seems like this attack surface has a fair amount of issues, both at like the logical level and also at the memory corruption level. So wouldn't be surprised if we see some more research coming out about this area. And it is very interesting where you have this Explorer integrated archive because it's something that people are going to use. It is a very convenient feature. If I'm dealing with like large archives, I tend to still use a dedicated program. Like I'll still use 7-zip or whatever to extract a large archive. But if it's something that's small or I'm just looking for like a file or two, yeah, I'll go through the Windows Explorer route because it's a lot more convenient. So yeah, it's a functionality people are going to use. It deserves to be looked at. So it's cool to see some research come out about it. And like I said, because I don't use Windows 11, I have no interest in it. But I wasn't aware that it had such an expanded support for different archive formats. So that's kind of cool.
Yeah, I had just kind of randomly noticed that it had support when I accidentally ended up inside of a 7-zip when I expected it to open up in, well, 7-zip. And instead I was in there and I'm like, oh, is this a zip file? No, no, it's 7-zip. And noticed the support that way. But
It seems to be sort of silent. I don't remember like any big like news made about it, but it is a sort of a big deal. So I was a little surprised, but yeah,
yeah, I
good
mean,
attack surface to look at.
I still prefer, like I said, using the actual like 7-zip or something because Windows. We actually ended up talking about this somewhat recently, but Windows extractions, when you're using their system, like drag and drops, will go through a temporary folder. Whereas if you're able to use the native software and just tell like extract to this folder, it'll go directly and you save like half the time if you're doing something big where, it doesn't need to write to OneDrive. In my case, it would always write to my temp drive or my temp folder, which is on my C drive, but I usually want to extract big things to a different drive. So I end up with it like writing to one drive and then writing to another drive and, just taking way longer. So I end up not using the default stuff. But
Yeah, and if you're someone like me who constantly has their C drive at like 6 gigs free, if you try to if you try to extract a large archive, you will run into problems with running out of space. Because the case that Z mentioned that we talked about recently was actually with me because I was using the drag and drop functionality, not realizing that it went through the app data on the C drive, and I had like a couple hundred gigs free on this other drive, and I was trying to extract there, and it was telling me I was out of space, and I was like, "What are you talking about?" I was getting very frustrated, but it was because it was running out of space on the C drive where it was going through the temporary folder because the drag and drop goes through Windows. Even if you're using an archive program, it still goes through Windows because of the weird stuff with how drag and drop works.
because of
So
reasons.
because of reasons, yeah. But that is a bit of a gotcha. Yeah, that is a reason. Yeah, like I said, when I'm dealing with large archives, that's why I use like 7-zip or whatever. Dealing with the temp folder and everything in Windows can be very annoying. But yeah, I mean that's a bit off topic, but yeah, an interesting set of bugs and an interesting attack surface. And continuing on file system type issues, we also have a post by Codan Labs on two bugs in LibreOffice. So I'll let Z get into these ones.
Yeah, and these bugs were kind of fun, kind of interesting, and the impact's a little bit interesting. Yeah, in LibreOffice, effectively one of them comes down to having an embedded file type, or sorry, having an embedded font. So in the actual like open document, what is it, ODT? Yeah, as an ODT file. So if you're not familiar with LibreOffice, it's kind of like Word. Well, it's kind of like the whole MS Office suite. You've got Word, you've got uh, like similar programs for everything. One of the interesting use cases with LibreOffice is it is used on the back end a decent amount. I'll get into that in a moment, but yeah, talking about the bug, the first bug here is path traversal leading to arbitrary TTF file write. And that just comes down to setting this font family attribute. Unfortunately, I'm the display I use to highlight the screen is acting up a little bit on this page, so if you see me kind of highlighting weird things, that's why. But yeah, this SVG font family, basically you can actually include a remote font that it'll try and pull out. From there, you can indicate like, yeah, load, whatever font, but you could also include a path traversal. So then when it goes and looks out of it's going to look inside of a kind of temporary embedded font folder. Get that kind of highlighted there. It'll look in that folder for whatever font family you're using, but you can have the path traversal and ultimately get. I am having a heck of a time trying to highlight on this page, but ultimately, you put that path traversal in there. And it will escape that. It'll look it up, potentially end up, if you have it embedded, it'll write the file to wherever you're telling it, but it is going to write a .ttf file, which does limit your impact quite a bit, I think. When it comes to exploitation, they have, a couple of thoughts here where they call out the headless usage in web applications, maybe a file right into a web root directory, or environments where other software watches for like config files in a specific directory. And I think that feels like the most likely, the last one feels like the more likely exploitation case to me, just because like log rotate is a really common choice for this, I think. If you can get into log rotate D, write a file in there, what you'll end up with is like it'll parse the file in a very permissive way where you can have a ton of things that make absolutely no sense and just like, oh, this line doesn't make sense, I'm going to ignore it until it gets a line that looks okay. So as long as you have like partial control, and in this case, I'm not even sure if you really need partial control, but then there is also kind of a direct way to having it run a command before it does the rotation. Therefore, you get command execution. So yeah, log rotate's a common trick for that. You can Google it. There are tons of exploits that go that route. And so the second bug is this environment variable and arbitrary INI file read. This one basically comes down to supporting a URL schema, being this VND sun star expand, and that ends up supporting, let's see if I can highlight here. That ends up supporting expansion. So you can include, they have the example here of a home, like a $sign home. So it's going to do expansions there. They call it as being very much like log4j. And yeah, it's that idea of put variables inside. This is a bit more limited than like log4j. Like you're not getting code execution out of it, but you are able to read properties out of an INI-like file. So it's just parsing it for like that sort of INI-ish format. INI, if you're not familiar, actually isn't like a specified format. There is like TOML, which tries to specify something, but INI itself, like it has a very common format, but it's not specified. So there's a lot of, things that are like INIs. Anyway, so it does that. You can read some variables, you can read some values out of it. So they use the example of just reading like a .env folder on like a developer's machine. And yeah, I think that's fair. Obviously, just having access to the environment variables. And one of the use cases that I think makes LibreOffice at least an interesting target is the fact that it does get used on the back end web occasionally. I won't say it's the most popular thing to use, because it would often be used if you need like a headless processing of documents and you need rendering. If you don't need rendering, you've got, I think it's like Apache POI or something that can deal with most like Office document types and like modify them, do your spreadsheet updates or whatever without doing any of the rendering. So like that's going to be preferred. But if you need rendering, LibreOffice is one of those things you can use for that, like, convert it to a PDF. It's like a really simple example, but there are other things you could do too. And so it does get used in that way. So you do have it running on the back end where there might be an env file where you might have sensitive environment variables that could end up being leaked. And yeah, with the expansion here, I should mention it would be an image source, so you could end up having it expand this image URL, so you'd get it going to an attacker controlled URL with the sensitive information in it, so like you get a leak out of it. I think that sort of attack is at least fair, but for the authors here, they don't really know what's going to be running it, what the environment is, so it is a bit limited. They have their example of attack of leaking sensitive email contents, and this one, it feels like a stretch on this one. Where you imagine a victim here that has LibreOffice, Thunderbird, and they manage a WordPress website. So you get them sent the forgot password email on WordPress. At the same time, you email them this malicious ODT or doc file that has the vulnerability, and that will extract the WordPress reset token from their inbox once they've opened the token, or once they've opened the document, and then you can go through the reset. Like, that's a pretty lengthy, I mean, it's not that lengthy, I guess, but that's a difficult like social engineering thing to pull off, especially when it's like a random document to be opened. Benefit here is like you're not getting the big warning like macros in the document, so like it's useful, I think, in that sort of case. Yeah, I could see it being useful in some situations. I think the server side aspect is more interesting, but it is more limited because like I can't think of any major projects that are using LibreOffice. It's more the type of thing that I think gets used where it's just like we need something really quick to solve this problem. And so they're just like, yeah, let's, call LibreOffice to like do this step for us, and it's just used in the backend, not like it's part of like a bigger like open source project. At least that's
it's probably not something you see in production ideally. Yeah.
Well, you don't. It would be used in production still, but it's more you don't know it's there. It's not something that like you've got these big projects that are using it. It's just like a random application that's using. Because I have seen it use it like I said, it is used with headless. So like PDF rendering is a simple example. Give it a doc, converts it over to PDF, and renders that. There are other ways to do that, of course. I wouldn't actually recommend going through the entirety of LibreOffice in order to do that. There are some other options for that, but it is an option, and like it does pretty good rendering on it. So that would just be a case where like it could be used in the backend. You wouldn't necessarily know what's being used for the PDF rendering from a doc file, though. And like usually that's not like something that an open source project is doing, or like one. Yeah, all I'm really getting at is it's something I have seen applications doing and using. It's not something where I can just be like, yeah, there's these big projects that do it, but maybe there are.
Yeah. The impact here is fairly interesting just because like being able to pull things from the environment and the environment files is pretty significant. It might not be code execution, but it's pretty common to store secrets in the environment, whether those be encryption keys or tokens or something. It's a common place to stash those. So could be fairly high impact on the servers where it is reachable. So
Yeah, definitely. Like I think there's a clear potential for impact. It's just really hard to recognize the impact because it's kind of like when you're dealing with exploits in libraries. It all depends on where that library is being used.
yeah, you have that dependency aspect. So definitely worth noting.
Yeah, and kind of fun bugs too, like the expansion issue. See it from time to time. Like it exists. It's one of those features that's just a little bit weird to see here, but Actually, it feels a bit excessive here. Like, I'm not sure why you need it. In, like, your Office document, I don't see any reason why you'd need uh, environment
And
variables to be expanded in there, like, at all.
that's pretty weird. Yeah.
Like, it is
It's
kind
hard
of...
to think of valid use cases.
Yeah, like, yeah, my image definitely is going to be in your home directory, or I can maybe imagine like a template directory, and then everybody has the same template. But why would you do it that way? Like
Yeah.
it makes no sense to do it that way. But that's why some CTO out there is like, yep, we're doing it this way. But
I
yeah,
didn't put too much thought into it, but it is a weird functionality to support in the first place.
yeah, like most likely it's just some libraries being used that has that functionality by default. It's not really thought about. It's there because they add more features to the library. I did
Fair
not look
enough.
into it, but yeah, they're still kind of like fun issues. I mean, the SVG thing, so the path traversal, is also kind of interesting. Just it's kind of deep in there. Like it's not an obvious place where you're going to look for a path traversal. It's just kind of deep, sitting in there. This random attribute, the font family. Like it makes sense when you think about it, but you have to think about and recognize, like, oh, I could try a path traversal here because this is going to eventually lead to a file, which is something to keep in mind. I mean, when you're hunting, it's
Looking for
half,
weird functionality. Yeah.
half the battle. Well, half the battle is finding the inputs that are vulnerable. Like,
Yeah.
you've got all these inputs where you could try all the vulnerabilities you want. You can know how to hack like every attack. But if the input or whatever you're testing on isn't vulnerable to it, you're not going to find anything. So, like, a big part of the battle is just finding these random things to try it on and thinking about it to try it on there.
Yeah. Getting into our last topic of the episode, we have a post by Hombre on patch capping the Google Container Optimized OS for $0. So, as you could probably guess from the title, this is a bug that at one point in time was patched in upstream Linux, but it was not patched in the KCTF container instance. Although, unfortunately, before they could finish their exploit, someone else had exploited the bug just a few hours before they finished. And the bug was also previously already exploited in KCTF as a 0-day, which makes it extra funny that KCTF had a patch cap for that bug. It's pretty weird. But anyway, the bug here is a use after free in the netsketch subsystem in the Linux kernel. The control flow for this bug is a bit complicated and somewhat long, so I'm going to skip over some of it, and if I get something wrong, I apologize, but it's very difficult to keep up with like all the nuances. But it has to do with queue disciplines for traffic scheduling. So queue disciplines can be both sort of stateless with no filters, which is they call classless, but they can also have classes which can have filters attached to them. Furthermore, you can replace a discipline on a class to update it. The problem is that replace functionality could be used to reparent a discipline to a different class, which leads to a scenario where two classes point to the same queue disk, which is not an intended state. That's not an intended design flow. Now, the consequences of that are where it gets kind of complicated, because the queue disk is reference counted, which may make you think, okay, this sounds like a weird scenario to enter into, but the reference count should prevent you from freeing the discipline from underneath the other class, which would be where your mind first goes to with how you would exploit this issue. And the reference count does prevent that. The problem comes into play when looking at the scheduler's active list, or A list. So when a packet is queued, if it's the first packet for that class, it gets added to a list of linked list heads that are tracked in its active list. And subsequently, when a class is deleted, it has to get, like, that queue has to get purged and removed from the class list. And it does this by calling this queueDisk purge queue function on the child queue. And that queue doesn't know that it's been reparented. So when it goes to refer back to the class to remove the A list, it uses the queue's reference to the class. So when you remove a class that had its discipline reparented, even though the class is freed, the reference to it in the active list still remains and it isn't cleared. So that's where you have the use after free potential. The way they got the use part of the UAF was when the packets are dequeued. So in this case, the like base class that was looked at was deficit round robin, or DRR. So DRR DQ would look up the class in the active list and use it to, among other things, invoke a function pointer call on the discipline's peak operation. So they had a direct path to code execution. Of course, it was a little bit tricky. It went through a few pointer dereferences, which meant that they would need to set up a valid fake discipline that would have like valid pointers to like the tables for them to hijack. That said, there were a few tricks they could use to make this work. For one thing, they didn't worry about kernel ASLR because by way of using the entry bleed side channel, which is it's a side channel issue with prefetch on Intel machines, which is what KCTF runs on. So by abusing that side channel, they didn't need to worry about ASLR. They could find the kernel base address. But even if they didn't have that, they could also just use the warn splat that could occur in the exploit chain due to the invalid linked list head. The other cool trick, though, which I don't remember us covering before, is you can abuse the netfilter xt match cgroups functionality, where you can store up to 1 page worth of arbitrary data, and that's stored at a fixed offset from the kernel base, where it's stored in kernel data. It's not stored in the heap. So that's super nice for getting controlled data at a known kernel pointer. Using that, they could fake the class to get code exec. They did have some troubles with ROP, mainly just due to the fact that they didn't have good control over a lot of registers, and their gadget selection just didn't seem to work out well for, trying to do a stack pivot. But they were able to find a single function gadget for doing arbitrary write, where this function would dereference the first argument, use that to write a value somewhere, and they controlled the contents of the pointer in the RDI register, so they could use that for arb write, which they then used to systematically overwrite mod probe path. There were a lot of details that I skipped over here, especially where it concerns the stumbling blocks and confusions they had for writing the exploit, which I think there's a lot of valuable insights there. It's just not easy to go into in like the podcast format. Basically, though, that process of trying to go from a simple proof of concept or report to root causing it and figuring out how to exploit it, they had some challenges there with having like incompatible kernel config. So, for example, they weren't able to reach the last step of the exploit where they were actually triggering the use after free, because the corruption where they reparent the Q discipline would cause the list head to be null when it goes to look it up to destroy it. And if your Linux kernel config had the config debug list option set, it would give like a warning and a splat like when that would happen. But the KCTF instance didn't have that config set. So, you kind of have those nuances with the kernel config changing the side effects of your exploit and what you're doing. And that's something that's maybe not necessarily obvious to you. And it's very hard to duplicate a kernel config exactly in a lot of cases, because you're going to have machine differences, you're going to need different things enabled and whatever. So yeah, I mean, getting into that information and how that put them on false trail and had them dive into a rabbit hole for a couple days that was stalling their progress. Again, it's just something where it's good for other people to learn off of too. To take that experience and save other people from having to go through that same pain. So there's a lot of that type of information in here. Very long blog post that has a lot of that kind of information if you're looking for it. But yeah, I just kind of went over the root bug. It is very interesting in the complexities and the control flow for actually taking advantage of it, because at first blush, if you just look at that reference count and be like, okay, it's reference counted, so I'm just going to ignore this, move on, look for another bug, I could definitely see that being the flow that you enter into as a researcher. You really had to dive deep and dig into what the potential consequences of this were. And that took a lot of, study of the subsystem and familiarity with it. So that's very cool.
Yeah, and on a whole, so it has like the technical information interleaved with thought process information, which I think is really valuable for pretty much anybody trying to understand the process of actually like doing the patch gapping, going through this, tons of useful information there. It does make it hard to like discern what the core bug is when like you're trying to say you're already hunting on Linux or like doing this, then you just want to like get what you can learn out of it. It's a little bit of that, but like it's a good post. There's a lot of good information throughout.
Yeah. Um, and like it kind of strikes at the heart of what good exploit development and vuln research entails, which is looking at these weird behaviors and trying to map out what the consequences are and how you can take advantage of that, rather than your straightforward like, oh yeah, this thing gets freed in an error path, but then the reference isn't cleared, so you can just, it's not like it's not your straightforward run of the mill exploit. It kind of requires that deeper thought process, which um is makes it a lot more interesting and lets you learn a lot more out of it. So very cool post. It is unfortunate that they weren't able to get like a payout or anything for this. It sucks that they were kind of beaten to implementing the patch gap exploit. Now they do say they're not even sure if the person who had beat them to exploiting it again is going to get anything anyways, because it was like as a 0 day it was submitted through KCTF. It's a very weird situation there. But still, like, this was a lot of effort, and they were mainly interested in, just the challenge of it, the fun, like the learning experience of it. But yeah, it sucks they didn't get paid out for this, because this is a lot of good research.
Yeah.
But yeah, KCTF as a whole is a great place to do research and get paid out for it generally. So
Yeah, especially
you always get good stuff coming out of it.
like a key thing really like it is good if you've got like a kernel vuln as one option, but the fact that they'll pay out on the exploitation side too, for novel strategies and such, I think is a big kind of win. If you're interested on the exploit development, they will pay out on like patch gapped issues or like end days. So
Yeah. So it's definitely worth doing, even though in this particular case it didn't pay out. But yeah, so that's all the topics that we have for this episode. So unless you have any last minute thoughts, see, we will end it there.
no, I think that's all for the week.
All right. So as always, thanks goes out to everyone who tuned in, and we will catch you next week.